You constantly battling electromagnetic interference in cables, control panels, or complex electronic systems. For systems engineers, understanding the basics of EMC electromagnetic compatibility and EMI electromagnetic interference is crucial. The right formulas can save you days of troubleshooting and help you design more robust, reliable systems. This video will break down the 7 most important and practical formulas every systems engineer should know. Whether you're working on industrial automation, robotics, or embedded hardware, mastering these formulas will help you tackle noise, crosstalk, and grounding issues with confidence. Let's dive into the essentials that will make your next project smoother and more efficient. Let's start with shielding effectiveness, or SE. This formula, SE equals 20 log E/E2, tells you how well a metal shield like an enclosure, cabinet, or braided cable reduces unwanted electric or magnetic fields. E1 and H1 represent the field strengths without the shield, while E2 and H2 are the strengths with the shield in place. For example, a shielding effectiveness of 40 dB means the interference is reduced to just 1/100 of its original strength. This is a critical calculation when deciding how thick your aluminum box or cable shield needs to be. Understanding SE helps you make informed choices that directly impact the reliability of your system. Cables can act like antennas if you're not careful. The formula E approximately I times F times L times K, R shows how much electric field a cable radiates when common mode current flows through it. The longer the cable, the higher the frequency, or the more current, the worse the emissions. That's why minimizing common mode current is so important. There's also the lambda/20 rule. If a cable is longer than 1/20 of the wavelength at a given frequency, it starts radiating significantly. For example, at 100 MHz, the wavelength is 3 meters, so keep cables shorter than 15 centimeters to avoid unwanted antenna effects. These rules are fundamental for keeping your designs compliant and interference-free. Crosstalk and shield quality are 2 more critical concepts. Common mode to differential mode conversion can sneak noise into your signals if cable pairs aren't perfectly balanced. The formula VDM approximately ZCM times ICM times delta/Z0 explains how even a tiny imbalance can cause significant noise. That's why twisted pair cables and symmetrical layouts are so important. When it comes to shielded cables, transfer impedance ZT tells you how effective the shield is. The lower the ZT, the better the shield. For example, braided shields typically have 530 m omega/m, while solid conduit can be less than 1 m omega/m. Always check these values to ensure your cables are up to the task. Finally, let's look at capacitive coupling and ground loops. When 2 cables run parallel, a small capacitance forms between them. If one cable has a rapidly changing voltage, some of that noise can jump to the other cable. This is called near-field crosstalk. The formula V coupled approximately C coupling times L times dV/dt helps you estimate how much noise might transfer. Separating power and signal cables or using shielded cables can minimize this effect. Ground loops are another common source of noise. If 2 devices have even a tiny resistance difference in their ground wires, current flow can create a voltage difference, leading to hum or ESD spikes. Using a single, thick, low-impedance ground bond is the best way to prevent this. Mastering these 7 basic EMC/EMI formulas empowers you to design safer, more reliable electronic systems. From shielding effectiveness and cable length rules to understanding crosstalk, shield quality, capacitive coupling, and ground loops, these tools are essential for every systems engineer. By applying these formulas, you can prevent many common noise and interference problems before they start, saving valuable time and resources. Whether you're building control cabinets, industrial machines, or embedded devices, these principles will help you achieve robust electromagnetic compatibility and keep your projects running smoothly.